So for this technical support system, it's going to be all text-based. We're going to type some things at the command line. It's going to respond to those commands after parsing the sentence we type and trying to understand it a little bit. This idea first came out of MIT in the 1960s. Joseph Weizenbaum created a program called ELIZA, which mimicked the behaviors of I believe it's a Rogerian therapist. So, I mean, there's an online version if you search for ELIZA Interactive Therapist. This is actually coming from Fullerton.edu, so Cal State Fullerton. Talk to Eliza. Hello, I'm Eliza. Hello? My name is Bill. Names don't interest me. What does interest you? We were discussing you, not me. Okay. So, I'm here because you are a useful demonstration of a chatbot. Perhaps you would like to be a useful demonstration of a chatbot? No, I prefer just talking without responding directly. And so on and so forth. So, I am being a bit negative. Okay, so as you can see, there are ways to analyze the text going on behind the scenes, and then it generates some sort of response, and it's supposed to get me to keep talking about anything so that it can try to either work with pre-canned responses that it thinks would allow me to believe that I'm actually responding to a human. And as you can see, when I try to leave, it now is in a part of its loop where it's like, okay, part of its analysis, it's going back to previously typed statements and trying to get me to feed it more data. So, with that in mind, we're going to do some work inside of these tech support projects. I'll leave it to you to open up Tech Support Complete, which is in the resources, and talk to the main tech support system and see how it responds to you. We're going to look at Tech Support 1, which is a significantly incomplete version, although it still has the same three basic objects. So if I go here and compile Tech Support 1 and make a new support system and tell it to start, it gives me this box where I can start typing. It's at the terminal. Please tell us about your problem. We will assist you with any problem you might have. I am having difficulty setting up my new workstation. That sounds interesting. Tell me more. I bought it on eBay. That sounds interesting. Tell me more. It used to run a nuclear submarine. That sounds interesting. Tell me more. Bye. Nice talking to you. Bye. Okay. So, as you saw, similar to Eliza, it has the ability to wait for input. It seems a little limited in its responses, and we'll see that it actually is. But if we go ahead and just consider what the main interactive loop needs to be, it's going to be something like this. While finished is false, or I'm sorry, Boolean finished is false, while not finished, do something, and then if the exit condition is met, set finished to true. Otherwise, do something else. We come back up. If finished is true, not true is false, and we get out. If finished is never reset, false, not false is true, and we just keep doing it over and over and over again. And we will see that inside of the body of the support system. So let me get this where it is hopefully readable, and if not, this is the tech support 1, so you have those files inside of the zip drive. My goodness, there's a throwback to the 90s. You have it inside of the zip file. And here we go. So our support system requires 2 objects, an input reader and a responder. And in the constructor, we make a new reader object, we make a new responder object. And then you saw me click start or invoke start. Boolean finished equals false. Print the welcome. While not finished, ask the reader object to get input and put it into a string variable. If the input starts with lowercase bye, finished equals true. Else, tell the responder to generate a response, put it into response, a string variable, and print that out, and come back and do it ad infinitum until we trip this condition set finish to true, and then we're finished, we drop out, we print goodbye, and we're out. Notice the main support system is doing very little work. Its job is to manage the I'm waiting for input, and now I'm waiting for a response, and I'm going to print that out. This is a great example of modularization. The support system needs the work from the reader object, the input reader object. The support system needs the work from the responder object. And as we go through the chapter, we're going to do a little bit more work in the support system to coordinate the communication between these 2 objects. But the things that deal with input will be localized here. The things that deal with generating responses will be localized here, and the way we turn input into useful data for the responder will be handled up here. So I guess it is worth noting that we don't actually use the input in the generate response for this tech support 1. In fact, if we go and look at the responder, generate response literally just returns the string, "That sounds interesting, tell me more." I don't know. Maybe you've been on dates like this. So it could be a reasonable facsimile of human interaction for some limited definition thereof. The reader object, if we look at it, get input, print out the prompt using its internal scanner from the so our reader variable is a scanner object reading from the input stream. Grab the next line, put it into input line, and give it back. Okay, all of these objects are doing what they're supposed to do. Let's look at the exit condition. The reader returns a string and we put it into the input variable, and then input is asked if you start with the character sequence BYE. But here's where it might be a little bit, maybe you know that there's a starts with method. Maybe you didn't know that. Where does it come from? What does it do? And more importantly, if we didn't know it existed, where could we find it? This is where reading class documentation comes in very, very handy. Now, I'm kind of old school Java. The class documentation that I'm accustomed to shows up in a 3-frame HTML web page format. All Java documentation is generally published in HTML. I'm old enough that I remember when I was learning programming that you would go to the back of the computer lab where there were stacks and stacks of binders that were chained to the desk, and you would flip through physical pages. So being able to have the documents hyperlinked in HTML, which was really quite something in 1995, um, was a godsend. And any programming language is going to have an API, and being able to parse that information and knowing where to look for extensions on that information is going to be part of the skill set you learn as a computer programmer, a game developer, a computer scientist. So as we're reading the class documentation, we're going to be looking at the application programming interface, or the API for that method or for that class. And it doesn't tell us how it's doing it, it's just going to give us the interface, and we can get the interface for all of the library classes that come to Java. So maybe you've seen this sort of screen before. We have a list of packages, and then if we have a package selected, a list of the classes and interfaces that are in that package, and then if we have a particular class selected, then we have the details about that class in the main pane. So I'm going to bring up my web browser. Let's bring this in so we can see it just a little bit. Java API 8. This will take me out to, well, it is possible when you install Java that you can install the docs right on your local system. I'm hopping out to Oracle's website. Oracle is the company that purchased Java and purchased the company that made Java many years ago now. So I'm going to look at the Java API, and we get those 3 panes. Now, if I don't specify a class, right now I'm looking at all classes, and there is a very long list. I happen to know that the string class is in java.lang. Remember, java.lang is the package that's implicitly imported, so we don't have to do an import statement to have to use Java strings. Here are the interfaces, and if I scroll down the classes, there is my string class, and if I click on string, then I have the information about the string class, information about its constructors, and then a summary of the methods. So keep that in mind. We're going to come back to this. And again, the URL to get there directly is going to be, let me insert a text box. Hopefully that is readable. https://docs.oracle.com Java SE/8/docs/API/ Might be faster to Google it. I will include that link in the class module as well. Okay, so our API reference gives us the interface, not the implementation. The documentation includes the name of the class, a description of the class, a list of its constructors and methods, and then the return values and parameters for constructors and methods, and a description of the purpose of each constructor and method. This is called the interface to the class. It is not a user interface. It is not a graphical user interface. It is the programming interface. It's the name of what you have to put into your program and the data types that you need to manipulate in order to use the class. The documentation does not include private fields. There would be no reason. The private field is internal to the class. we don't need to know about them because we're just using the class. It wouldn't include documentation for private methods by the same reason. The access modifier of private means that we as an outside class cannot access them. And it also will not give us the bodies or the source code of the methods. Side note, if you are interested, you can download the source code for the Java classes and go through and see how they are written. But you don't need to do that in order to be able to use them. All of these things, the private fields, the methods, the bodies of the public and private methods, are the implementation of the class, and we don't get those in the documentation. So let's look at the starts with method and a couple of other elements of the string method, and understanding how to read the documentation for more complex classes, and then we'll take a break. So, looking at starts with, the method header for starts with, the interface for starts with, it's public, it returns a Boolean, its name is starts with in camel case, so first word lowercase, and any word following would be an uppercase, and that's known as camel case. And it takes a single parameter of type string, and that string has a name that we don't need to know about, but it's descriptive. This is why you want to choose descriptive parameter names. It could just be string S1, and it would still be the interface, but here it's telling us that this string is the prefix, which means that, from an English language perspective, a prefix would be the part that starts the word. And so what we want to do is pass in a sequence of characters that we want to ask, is this how the string that we're looking at starts? So the method description tests if this string starts with a specified prefix, and then what are the parameters? Now, sadly, usually what will happen in Java documentation is it is good practice to list out your parameters, but if you choose your parameter names wisely, the parameter prefix is the prefix. Well, okay, if you understand kind of what the class is supposed to do, that might be enough, especially with the callback to the does the string start with a specified prefix. But sometimes you'll be reading the documentation and it might seem a little redundant. So finally, it returns true if the string starts with the specified prefix and false otherwise. Okay, that sounds like it could work. The important thing about starts with is it has to be an exact match. I'm going to restart my tech support system. Type by to exit our system. Capital BYE. Doesn't match. Uppercase BYE. Doesn't match. Space BYE. Doesn't match because the first character of the string is a space, even though, the first character that is readable and meaningful is the B for BYE. So if I type bye-bye, that does match because the first characters are BYE. It starts with those. The string class has a number of other methods that are useful to know about. Contains. Rather than starting with, does that sequence of characters exist anywhere within the string? Ends with, is this the last pattern in the string? Index of, does this character or sequence of characters, if it is in the string, what is the location of that string, starting at position 0? Substring, take a piece of that string and pull it out. To uppercase, take your string and make it all within the ASCII range from character capital A to capital Z. Trim, remove any unprinting white space from the front and back of the string. What you may want to do is come into your code pad over here and string s1 equals hello. S1 is hello because I can't type. S1 dot to uppercase. I can't type. Have I mentioned that? Uppercase. Not sure what's going on with my keyboard. And now it's hello. So you can play around with some of these methods inside of the immediate mode of the code pad. It's worth experimenting with. Okay. Now, when we use library classes, all of these classes are organized into packages, and if we want to use a class that is not part of the core of the language or Java lang, which is imported automatically, you need to use an import statement. Once they're imported, they can be used like classes that are written inside of the current project. Going back into the support system, we don't need to import anything here because input reader and responder are classes that are created inside of this project. But the input reader right now needs to make use of hash set at some point in the future and also needs to make use of scanner. So we're going to import those classes so that we can make use of them at a later date. When you are importing classes, it doesn't import the code into your project. It just lets the Java compiler know that when the time comes, it can link those classes in as needed. So you can use a single class by using the specific name. You can import an entire package. My preference is that even if you have multiple classes from a package, that you list them all out, because that helps to document for people reading your code a little bit about which classes are necessary for the implementation, which will be of big help for people that are maintaining it over time. I did not mean to move things forward quite that far. One of the things that would be useful for us to be able to do would be able to choose random values. So, instead of saying the same thing over and over again, maybe if we had a collection, even an array list, and we chose one of the responses at random, that would be better than just saying, that sounds interesting, tell me more. If we want to do that, we can use the utility package, the utility class random. The way you generate random numbers in Java is to create an object of type random, and then ask that object of type random, to grab the next piece of random data that you need. If you ask for a random next int, it'll be anything within the range of possible integers. If you ask for random next int with a limiter, it'll be from 0 to 1 less than this. So if we wanted a number from 1 to 100, we would say, give me a next int 100, that gives me 0 to 99, and then we add 1 to it, and that moves us into the range we want to be in. So if we had a list, an array list named list, that object could, whoa, strange jumpiness. That object, the list object, could be, we could request the size. So if we have 5 items in the list, this would come back as a value from 0 to 4, and then that would be a valid index for something inside of the list. So if we wanted to do this and maybe select random responses, we could ask our responder to be a little bit more complex. It could generate, could have a random object inside of it, that we could construct in the constructor or initialize in the constructor. We could have an array list of strings, and we would have a method called fill responses that puts a bunch of strings inside of that array list. And then when it's time to generate a response, we do not use the scroll wheel. We just point and say, ask our generator to randomly choose its next integer from 0 to the size of the list. Return that as the index, because remember, we're only getting a number here. We'll go to our array list and get the value at that index, which is a string, and we'll return that. If you look at tech support 2, you'll find an example that does that. Now, before we wrap this part up, it's worth keeping in mind that some classes require more information to do their job. These are parameterized classes. So for instance, if I go back over into Java util, so I'm in the Java docs now. If I go to Java util and I look at my array list, class array list E. This is a parameter. It needs to know what we're storing in that array list. So if it's an array list of string, E stands for string. If it's an array list of ticket machine, E stands for ticket machine. If it's an array list of book objects, then E stands for book objects. As we're going through that, we'll see that if it's an array list of something, some methods, like the get, will return the data type E. So where is my get method? My get method returns data type E. So again, an array list of book, get a book. An array list of student, get a student. An array list of string, get a string. And then some methods like add require a data type of E. So if it's an array list of string, I can only add strings. If it's an array list of books, I can only add books. So you're going to see that designation, and it just means that it's whatever we declared the array list to hold. It's a placeholder for element. So as I was just mentioning, since we did the music organizer last chapter, an array list of track, when we get something from the array list, it is a track. If we are adding something to an array list, we are adding a track. Okay, let's wrap this portion up and then you can take a break. What you need to keep in mind, Java's class library is huge, right? We saw that. If I go back and look at all packages, all classes, it is a lot. You don't need to know all of them. Okay, there's going to be some you use a lot, going to be some that you kind of know and you might need to go, and there are going to be some that you will never touch or won't touch for a decade. That's okay. So you should be familiar with the classes you use a lot, and you should be familiar with the structure of the library, because that API documentation tells you how to find the things that will be useful to you. It's very tempting to skim over the documentation, and sometimes it's enough just to look and say, okay, here's the object and here's what it can do, and here's the method I need. And then sometimes you really need to read deeply about what that object can do. I guess my recommendation is don't start reading deeply at the very first thing you do. Try something. If it works, poke at it, make sure that your tests are really solid. But then after you see how it's being used and what's happening with it, go back and really figure out what they've told you that object can do. And then last but not least, keep in mind that some objects are these parameterized types and they will require more information in declaration and usage. Okay, when we come back, let's make these support systems more robust. And I'll see you soon.